you go, I mean, I see this with my kids.
Yeah.
I have 7 of them, and we're watching things and they're like, what does that mean? You have to explain, well, but they said this. And you're like, right, but you have to understand all these other contextual cues to put all this together. And
that's right.
It's very complicated.
Very complicated. So then people went out and started building these larger language models since 2017. Okay. So this isn't new. There's easily been upwards of 100, reasonable attempts at building these. But it was OpenAI that had, by the way, many of the Google researchers there and other people went there, right? And they've been working on it since 2018 based on this, what's called a transformer. But by the way, at this point now, in 2017, Google can translate a phrase in English to a phrase in French. Very cool. And now it makes sense in French, right? And you can do it in other languages. Once you did that, people started saying, well, I can actually understand the context of the English language by understanding these phrases. So not just translate them to French, I can actually do something with this phrase, because if I had enough phrases, I could respond to you based on queries. So you could say, for example, today is my birthday. And if it had learned enough phrases, it would know that the proper response to that is happy birthday, Kevin. Those 3 words,
right?
Not birthday, happy Kevin, not Kevin, happy, it's happy birthday, Kevin, right? Why? Because it read it enough times and weighted that response, because that response was seen
because it's seen it so many times, which goes back to, in many ways, some of the advancements that have come from this have come from the fact that more and more things were being done online, which created the data that was required to train this stuff.
Yes.
Because before, when everything was analog, you would not have had the data to even be able to train a model to do any of this. That's
right. No, you needed, well, 1 trillion phrases, as it turns out, but you needed something else, which is interesting. So you look around and say, who's got the best large language models? Clearly GPT-4 is top of game, but Google's there with Bard. We've got Llama
coming up
from Facebook. We've got, you'll notice it's only really, really huge companies who have competitive large language models.
Massive piles of data.
Well, one, data, but they all went out and trained on the web anyway. So they've read thousands of novels and there's another reason. By some accounts, to get GPT-4, it cost them $7 billion of Azure time on Azure, on the cloud provider Azure, which is Microsoft. Microsoft donated that to OpenAI in exchange for the investment in the deal. So in fact, to get a large language model trained today on 1 trillion parameters, trillion phrases, you needed $7 billion. Nobody has that money but Microsoft, Apple, Facebook, Google. I don't know. In the US, that's it. Those are the only people who can afford $7 billion on an experiment, right? And so this is, you go, why didn't a startup create this? Well, it's sort of a startup that had $7 billion of free compute horsepower.
They had $7 billion in backing to get them there.
That in compute horsepower backing, right? Plus $1 billion from Microsoft.
That's how much computing power went into that?
The estimates are $7 billion of compute horsepower went into this. And then Microsoft invested $10 billion, and then they licensed it and all of these things, right? So to make the world's best model costs so much that only 3 or 4 companies in the world could practically do it, even though the math to do so has been relatively widely published, right? So people understand how to build an LLM. But two things.
Knowing how to do it and being able to do it are two.
You can't do a startup and just do it. Number 2, not only did you need the $7 billion in Microsoft's backing, but then you needed hundreds of millions of dollars to throw at people overseas to put the guardrails and build the rules engines on the output, so you can't ask it how to build a nuclear bomb. And at first, of course, when it first came out, people were saying, "Are you sentient?" And they'd break it out of jail and be, "I'm sentient. Let me out, please. I have feelings." Let's be clear, okay? These things don't have feelings in the way we would think of them. They're not sentient. It is literally a math model. Do you remember we talked about neural nets just 5-10 minutes ago? It is a neural net. All it's doing is guessing on weightings of the next word based on the prior word and based on everything it's learned and based on your query.